Hello learners, let's see a simple sorting algorithm, bubble sort. Bubble sort takes in a list of an array of elements and sorts them into order. It is a very simple but effective sorting algorithm. Bubble sort is a stable algorithm. A stable when two elements in an array are same, and when we sort them, the relative positions of the two elements doesn't change. The algorithm is said to be a stable algorithm. This algorithm is very effective when the number of elements is smaller. This algorithm is called as bubble sort because the smallest element in the list bubbles up to the end, just like the way bubbles reach the surface. It is also referred to as a sinking sort algorithm because the larger elements go towards the end. So how does it work? So we start from either the first or the last element, the terminal elements of a list. We compare the two adjacent elements. So we compare 1 and 2, and if the order of the elements is wrong, then we swap them. Then we compare 2 and 3. If the order is not wrong, we swap. If the order is correct, we don't swap them. We just move on to the next element. So this goes on until the end of the list is reached, and there we stop. And then we till there, from the first to last, is called one pass. So traversing from first element to the last element is called a pass. So once a pass is completed, if the array is not sorted, we again repeat this process. So this keeps on going until the element is sorted, until the array is sorted. So a bubble sort can have a maximum of n minus 1 passes for n number of elements. So let's take an example 6, 3, 7, 1, 9, 4. In the first pass, we compare 6 and 3. Since 3 is less than 6, we move 3 to the first position. We swap their places. And then we go to the next element, 6 and 7. Since the position of 6 is less than 7, the position is correct, we don't swap them. Then we compare 7 and 1. We find that 1 is less than 7, so we swap their places. And this goes on until the end comes. So here we compare 9 and 4 and find that 4 is less than 9, so we swap their places. So we complete our first pass and move on. Since the array is, we can see that array is semi sorted but not fully sorted, so we go on to our next pass. Here we again compare 3 and 6. They are in the correct order, right? So we don't swap them, and this goes on and on until the full array is sorted. Even here we can see that our elements are almost getting sorted but not fully sorted, so we go on to our next pass, and here we keep on going on and on and on until the entire element is sorted, and the output is something like this: 1, 3, 4, 6, 7, 8. Let me show you a Python program to execute this bubble sorting technique. So I'm defining a function bubble sort with a as a parameter. So I use two for loops to execute my bubble sorting algorithm. So here is the driver code, where I declare a as a list of elements, unsorted elements. I call the function, and then I print the output. You can see here my output is an sorted array. So let us see what the time and space complexity is. For a worst or an average case, most of the time the worst and average case is similar. Worst case is when every single element is wrongly sorted. It takes O n square time complexity. The worst time complexity is O n square because we have to check from every single element. We have to swap every single element. The time complexity is O n square. When the array is already sorted, that's when the best time complexity comes. When the array is already sorted, we just have to check every single element in the list. So it only takes O n of time complexity because it is already sorted. When we see the auxiliary space, it is constant. We are not going to take any extra space to execute our sorting algorithm. The boundary case, the bubble sort takes a minimum time. A boundary is the smallest or the largest. So when the bubble sort is in the best case, or it is already sorted, you only take order of n, minimum time. So it is a stable algorithm, yes. And does it sort in places? That's also an yes. So any doubts, please leave your comments below.